So final talk by Elena Popova from Chile, our Western speaker, Universidad Bernardo Higgins. So the floor is yours. Yes, we see your screen and you can start.
I will make a small review about types of flare precursors. And show some main types. Search for precursors is part of prediction of space weather. The term of space weather usage of term space weather was started from middle of 20th century and the moment of 20th century. So the definition what is space weather. Space weather refers to conditions on the sun and the solar wind, magnetosphere, ionosphere, and thermosphere that can influence the performance and reliability of spaceborne and ground-based technological system and can endanger human health. Adverse conditions in space environment can cause disruption of satellite operations, communications, navigations, and electric power distribution grids, leading to a variety of socioeconomic losses. For example, here you can see a scheme what is main object of effect of space weather, processes of the in sun. It can be satellites, aviation, and power grids. Range of space weather scales is extremely challenging. Relevant time scales vary from 10 the power -9. It's like plasma fluctuation in the solar atmosphere, to 10 to the power 8 second. It's like a solar cycle. Relevant spatial scales vary from 1 meter. It's like ionospheric plasma structures to 10 to the power 8. It's like large-scale interplanetary plasma structures. For example, flares on the sun, it's a part of space weather. They can affect some different devices, and it's like chronology of main solar events like flares. During 1 hour, you can during a flare, it can be loss of log, a loss of signals. From 15 minutes until 40 hours, it can be like energetic charged particles mission, and during this it's microelectronic upsets and radiation dose can be on satellites. Some losses of signal near poles, it's microelectronic upsets, passenger doses. It's an aviation. In 15 hours till 3 days, it can be like transformer heating, voltage instability, loss of logs, reduces accuracy, surface charging, less frequencies, more interferences, internal charging, and radiation dose too. So it's like an effect of solar flare activity. One of the key factors of space weather is solar flare activity, the monitoring of and prediction of which is an important task of specialized dedicated groups of space experts and solar astronomers. Solar flare forecasts are made on the basis of identifying and detecting so-called precursor specific processes and solar activity events that occur before flares. Some different space agencies and some companies can make monitoring of space weather and make prediction of solar events for forecasting of space weather. Here's example screen of from NASA monitoring of like some events on the sun, and for prediction can be used some physics-based models. Some set of models that exist, and a lot of observation data now available, and groups have tools to predict space weather like models and data to feed them. And also we have archives of historical events for investigation of such activity and consequences. Here is example of monitoring of space weather events. It's like monthly reports. It's from NASA. Here you can see examples like activity type, some, for example, active regions, flares, some classes. Here, like a magnetic classification of active regions. Here's like type of flares which was during this period, and type of them, and other processes which was detected by those satellites. So I remind basic scenario of solar flare. It's like first stage is dynamo processes of magnetic field generation, for example, by dynamo processes like alpha omega coupling accumulates magnetic energy of the toroidal field inside the convective zone. Some of this magnetic energy can be carried by magnetic flux tubes floating up to the surface of the star and popping up and form the spots, like in case of sun. The configuration of magnetic field in sunspot involves overtime, and flare appears when it becomes unstable. Then the flare releases a part of the free energy of the magnetic fields through the mechanism reconnection of magnetic field lines. From general consideration, the energy yield of the flare must be related to the size of magnetic spot. There are stars which is much larger spot than the sun, thus with more powerful flares. Such stars must exhibit faster rotation in order to support stronger dynamo coupling. And here's like standard model solar flare scheme for precursor during a flare. It can be emission of accelerated electron, and on the basis of the soft X-rays, and also emission of microwaves via transformation of electron plasma oscillation into electromagnetic waves and synchronization in magnetic fields. What is the stage of a solar flare? First is a precursor stage. The release of magnetic energy is triggered soft X-rays emission is detected in this stage, and can be other precursors. And second impulsive stage, protons and electrons are accelerated to energies exceed 1 MeV. During the impulsive stage, radio waves, hard X-rays, and gamma rays are emitted. The gradual build-up and decay of soft X-rays can be detected in the third decay stage. The duration of these stages can be as short as few seconds or long as 1 hour. What can be type of precursor in the first stage of solar flares? It can be found by analysis of dynamic of sunspots, by analysis of magnetograms, by analysis emission of X-rays, and by microwave emission. First type of precursors, dynamic of sunspots. It can be detected in special behavior of sunspots. There are some different papers which are devoted to this topic. And the sunspots can be precursors of solar flares, and operational forecasters tend to use a standard sunspot group classification system, which is commonly used as a proxy for complexity. Several papers provide evidences that the most probable sites of flare once at the regions of high horizontal magnetic field gradients in solar active region. And here's an example of such papers, a type of papers which used some dynamic of sunspot. It's, for example, such paper. It follows the behavior of suitable defined proxy measure representing the horizontal magnetic field gradient. The source of the data is SDD sunspot catalog. The most promising pre-flare signatures are following properties of the gradient variation, step increase, high maximum, significant fluctuation, and gradual decrease between the maximum and the flare onset, which can be released the pull mode of the current layer. There is property a tool for the assessment of flare probability and intensity within the next 8 to 10 hours. And other type of precursor can be found from analysis of magnetogram, and after use, for example, analysis of magnetogram from different databases, and use some model like classification, or some make some special algorithm, for example, using deep machine learning or some statistical algorithm, and which enable to train classification models to achieve almost a good performances using active region parameters provided in, for example, different catalogs. In this paper, for example, in space with active region patch data files. Such, for example, such type of work, it's like a combination of several methods with it's like statistical algorithm and different and deep machine learning. They found like a prediction score around 20 hours before strong solar flare events. And so it's like they found some special regions can be which can be precursors. How it can be like calculation of flare probability. Once the active region have been classified, the next step is to calculate the probability of a flare occurring in this region over the next, for example, 24 hours. There are many ways to do this, including Bayesian method, machine learning, discriminant analysis, and other type of some algorithms, mathematical algorithm. For operation flare forecasting, a simple statistical method is often used, along which a little human intervention. Forecasters will first rely on a large database of flare information from previous solar cycles. This database shows how many particular classes of flares, how many, for example, M or X flares in active region, or that classification produced in that time period. From this, an average flare rate can be calculated, and using Python statistics, a percentage probability of flare occurrence for the next 24 hours. For example, some can be obtained for each region. If some operational forecaster thinks that value determined by the model is too small or too big, or some has some different they can change it based on their experience before using it. The percentage for each region can also be added to obtain the probability of flare occurring across a solar disk over the next 24 hours. Other type of precursors, it can be X-rays. It can be different type of X-rays. It's like soft X-rays and hard X-rays. Two stages of flares have a different type of X-rays. Thermal phase has soft X-rays, and impulsive phase best observed in hard X-rays, and precursor phase observable in soft X-rays can also be conjectured to occur before the onset of flares. If this phase exists, it not only imposes an additional requirement on flare theories, but also has practical significance for flare prediction. Other type can be like microwave range. So here is like examples of works which have deal with a microwave range. It can be study, for example, first paper after study precursor of flare using the represented spatial temporal resolution of the 1.6 m new solar telescope, complemented by new microwave data, and 2 episodes of precursors brightening indicated a small scale magnetic channel as multiply polarity inversions and enhanced magnetic fluxes and current lying near the footprint of shared magnetic loops, microwave spectra collaborate in this precursor emission originate in the atmosphere. This result provides evidence of lower atmospheric small-scale energy release, possibly linked to the onset of the main flare. In Abramov and his quarter, authors present a study of a spatial distribution of quasi-periodic oscillation of microwave emission into active region before M-class flares. Two events were studied. It's like on September 6 and September 25, 2011. And Nobiyama radioheliograph daily observations were used at the frequencies of 70 gigahertz. In both cases, after found the pre-flare wave strengths of brightness, temperature, oscillation of microwave emission in active region. The duration of wave strength is about 3 or 4 pulses. It was found that the source of oscillation was compact zone in active region, which coincides with the place of maximum brightness during the flare. But nanoflares can be other type of precursors. It was in first work was suggested in Parker paper. It's some small flares. Nanoflares. They can there can be a lot of tiny objects in chromosphere with sizes only tens of kilometers. All processed in nanoflares are small copies of ordinary flares. There is energy is released in the process of magnetic reconnection. If the nanoflares activity intensified in an area of suspicious magnetic spot before a big flare, they might be detected by solar radio telescopes as kind of enhanced background or even as a branch of smaller spikes. Until recently, individual nanoflares are very irresolvable. Now there are claims that Parker probe was able to resolve them in few cases. Spatial scale around 60 kilometers and detailed systematic study by solar radio telescope data accumulation and correlation analysis with flares are needed in order to evaluate their role as precursors. So it can be like a field for further research. And it's like conclusions are all of models. They have horizon still as maximum 24 hours, and none of proposed model provides the necessary requirements for the accuracy of prediction, and accordingly, most of the models has not been included in the regular set of space versus service. And I would like to mention that we propose use Ventspils International Radio Astronomy Center and of Ventspils University, in particular radio telescope at 32 for regular research of solar flare precursors, like for example, increasing of nano flares. We would like to try make regular research and apply for some proposal for this. Thanks for your attention.
Thanks, Elena. Thank you for your talk, and very interesting. So finally, as I understand, maximum possible time scale that can be predicted flare is around 24 hours, right? So
yeah,
we can speak for longer periods.
Yes, it's like a challenge to find something which bigger horizon, but still all groups or some different groups has only models with horizon 24 hours. It's quite good prediction.
Yeah, so it's quite challenging and probably a very urgent task for space weather and space safety. One more question from Abhishek. Abhishek, could you say?
Yeah, hi, Lina. I have one very general query, because there are several mechanisms proposed for the precursor. So can we unify clearly the energy release process during the precursor with the same in main phase of the flare? Like, is there any clear linkage, or maybe something is different there?
Can be like I mean I see your question in the chat. It's I think this one, and it's I spoke about processes during precursors with some emission of some, for example, X-rays or microwaves as consequences of emission of electrons. Or if we will monitor some nanoflares, it can be like main phase of flare, but it's main phase of smaller, very small flares.
Okay, thank you.
Thanks again for Elena, and thanks for all speakers.